The quadratic formula, I'm going to jump around a little here because I'm tight on space. Quadratic formula says x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So you should remember this from previous classes and be ready to use it when the occasion arises in this class. But for this equation here, you should have your quadratic equation in the form of 0 is equal to ax squared plus bx plus c. Okay, so I'm going to take this and I'm going to put it in this form. So I'm going to we'll bring the t2 squared over to this side. So then I would have 0 on this side. I want to put the t2 squared term first. If I bring t2 squared over to this side, that's minus t2 squared. So it's minus t2 squared plus 1/2 t2 squared. So altogether that is minus 1/2 t2 squared. Then I have the minus 16 times t2 plus 350. Now I'd rather have a be positive, so I'm going to take this and I'm going to multiply it by -1, which makes this positive and this positive and this negative. And now this has the form 0 is equal to ax squared plus bx plus c, where the 1/2 is my a, my b is 16, and my c is -350. So then using the quadratic formula, I have not x, but t2, since t2 is playing the role of x here. So I have t2 is equal to minus 16 plus or minus the square root of 16 squared minus 4 times a, which is 1/2, times c, which is -350, divided by 2 twice a, so that's 2 times 1/2. Okay, at this point, I'm going to let you plug this into your calculator, and you should get 2 solutions here. So one for the positive, the plus sign here, and one for the negative sign here. So those 2 solutions are 14.9 and -46.9. This is for time 2, so the unit should be in seconds. And time 1 was equal to 0, so time 2 needs to happen after time 1, so we're going to reject the negative solution and choose the positive solution. So the negative solution still means something, but it is not valid for time 2. So if you went back in time with the same acceleration for the truck and the car, I'm going to make a mess of my motion diagram doing this, but I think we have everything we need from the motion diagram. So if the car kept the same acceleration earlier in time, it would have looked like this. If we kept the same acceleration and we go backwards, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to stop there. And the truck keeping the same acceleration and going backward in time would look like this. So if we go back far enough in time, because the acceleration of the car has a greater magnitude than the acceleration of the truck, which isn't actually true in my motion diagram here, but you can still picture going back over here. The truck is slowing down here. The car is slowing down, but the truck is slowing down slower than the car is slowing down. So they would actually have passed somewhere back here also, if we went back in time, and that's what the -46.9 seconds means. Which might make sense in certain situations, but the car was at rest to begin with, so we shouldn't say that it had this acceleration before time was equal to 0. But if it did, they would have passed somewhere back there. Okay, so I have my time here. I can put it in, that's T2 for the car. It is also T2 for the truck. I circled it, I should box it. Okay, now I can finish the problem, so I'm going to finish the problem over here. And to finish, let's see, I need to find R2 for the car. I can do that using this equation here. You know, probably it would have been helpful to call this equation 1, not to be confused with event 1. So equation 1, equation 2, equation 3, equation 4, and then this came from 1 and 2, and this came from 3 and 4, and now here we're going to use equation 1, and we're going to find T2. No, we're going to find V2C. So V2C is equal to twice times T2. Don't put the units in because we didn't put them in this equation. So twice 14.9, and that gives us 29.8. That's meters per second. And let's box this. And how do I find R2? I can use this equation here, or I can use what I got from equation 3 and 4, but it looks like it's going to be easiest to use this. So that equation doesn't have a number. I could give it a number and call this one equation 5. And then using equation 5 here, I have R2 is equal to T2 squared. Now again, don't put in the units because we didn't use them everywhere along the way. And this is 222. Okay, and then so that's 222 meters for the car and for the truck. Then I just have to find V2 for the truck, which I can find using this equation, which isn't exactly equation 3. It's equation 3 with the negative 16 on the other side, but we'll just call it equation 3. So this is T2 14.9 minus 16, and that is minus 1.1 meters per second. That's the last thing that we needed to find. We can put this in our table here. Okay, and we can even check our answer in the back of the section. So this is 14.9 for T2, which is what we got. Okay, if you go to check your answer in the back of the book and your last significant figure doesn't agree with what we have here, so let's say this was 14.7. Well, they only gave us 2 significant figures in the problem, so we would round to check our answer. If it's a little off, round to 2 significant figures. So this rounds to 15. If we got 14.7, it would also round to 15. So if your last significant figure is off, it doesn't mean that your whole answer is off. Also, when I'm doing the problem, I'm not plugging everything into the calculator as I go. I've actually solved these problems in the past, and I'm using those solutions to do the math rather than plugging everything in the calculator. And I may have done it a little differently in the past. So, like last time I did it, I got 220 meters. Okay, so that was a little off. And when I redid it this time, I actually did plug this in the calculator as I was doing it and got 222. But if you notice when I'm doing example problems, if I have something like this is equal to 220, it's just because I'm not actually plugging things in my calculator as I go. So it's just off a little due to rounding in that case. Okay, so as long as the final answers, I mean, if you round it to significant figures, if they agree, then we're not going to worry about it. Okay, so that concludes problem 52.